Okay, thanks, Eleanor and the CMIP IPO for inviting me to this CMIP seminar series. I'm Masa Watanabe from the University of Tokyo, and I'm a WGCM member as a Japanese modeling representative. And my talk today is not about a specific scientific issue, unlike the previous talk, but a kind of personal thought about how and why we keep doing the climate modeling. And I have a four major bullet point which I'd like to share with you. I cannot move uh, cannot move the slide. Okay, it's coming very slow. Okay, I believe everyone could agree on the first bullet point, which says the climate model or our system model is an essential tool in climate science. And there are a bunch of good examples demonstrating this, but I just pick up two out of them. One is work by Kosaka and Shea, focusing on to reproduce the global warming pose by doing the so-called pacemaker historical experiment. In that, the tropical Pacific sea surface temperature variability has been nudged to observations to constrain the model work. And you could see the pacemaker run reproduce much better than the CMIP 5, I guess, the historical runs to reproduce the warming hiatus. This was clearly relevant for attributing the past climate change. And this specific work tells us if we know the historical change in the tropical Pacific SST, the warming pulse could be reproduced quite well. Another example is the use of climate model to support theoretical understanding of the climate system. And the Sarah Kang and the others have proposed a theoretical argument about the shift of the tropical rain band, aka ITCZ, in response to the hemispheric summer contrast. In the schematic, you're seeing the heating in one hemisphere and the cooling in the other hemisphere, and your hardware cell is supposed to shift to transport enthalpy and the potential energy toward the cooling hemisphere, which automatically accompanies the moisture transport to the opposite direction and shift the ITCZ toward the warm hemisphere. And again, the climate model experiments were critical to verify this theoretical argument. And here we go back to a kind of old days of climate modeling in the 1960s. I adapt here to Japanese giants in climate modeling, the Akio Arakawa and Suki Manabe. And you would be familiar with what they did about the convective parameterization or building the one-dimensional radiative convective equilibrium model to explore how the temperature profile responds to the doubling of the CO2 experiment. And I would say their work were part of the pioneering of climate modeling activity, and there's no doubt their works were scientific. And you have seen this sort of diagram many times, showing how the models have evolved over the past decades after the 1960s. And the many different model components have eventually been integrated into the single climate model or our system model. And now we probably have three different dimensions in the modeling. And one is to increase complexity, which was presented just in the previous slide, to incorporate more components such as the carbon cycle, biogeochemical processes, and even human components. The second dimension is to increase horizontal and vertical resolution, which I will come back soon later. And third dimension is to increase the ensemble size, which is quite popular now after CMIP 6, I think, by repeating the historical or the scenario experiments with perturbing the initial conditions, we could separate the climate change signals from the internal variability much better than the multimodal ensemble. And we are here in the 2020s, and the model has now a greater divergence, and it became more complex. And there may be a critique that with such a complex model, no one could understand what's going on in the model. But we could make a kind of rebuttal to such a critique because we could understand processes by using a hierarchy of the model from the very complex one to the idealized one, or the component. Another thing I would emphasize is the model tuning, which is more important to close the energy budget, especially in the coupled atmosphere-ocean system. And the critique to the model tuning has been repeatedly spoken because the tuning looks like the engineering, but not science. And I would say no. The science could be stimulated by model tuning. And I remember about a decade ago, the model developers got together to have the workshop named the Climate Model Tuning Workshop. And the summary of the workshop has been published in BAMS. And the left-hand side panel is taken from that paper showing the global mean temperature time series from observation and the three perturbed experiment with a single model. What is interesting is here is the model has been retuned by just changing a single parameter of the cloud microphysics process. And the blue one, which is the most apart from the observation, was the kind of best fit in terms of the cloud microphysical process. And the modeling, the people are aware of the errors in the model tend to compensate each other to determine the model mean state. On the right, this is taken from my own paper many years ago, demonstrating that the large-scale model variability, the ENSO in this case, can be controlled by perturbing a single parameter in the convection scheme. As such, the model these have a value in understanding how the climate system fluctuate or evolve in time by understanding the impact of the small scale processes on the large scale climate fields. And over the past 3 CMIP cycles, we would have been asked ourselves how much the models have been improved. And the left two panels were taken from the AR6 report and showing the pattern correlation of the model mean field with observations. And you see that the correlation is almost 1 for some variables such as the surface air temperature or zone potential height, but other quantities such as precip, the radiation, and the clouds have still much room to improve, and the improvement may not be expected. It may not be sufficient than we expect. And the model resolution has, of course, been increased from the CMIP 3 up to CMIP 5. But this is also a kind of eventually, not radically. And the many modeling centers in the US UK, Germany, and Japan as well, have promoted the much higher resolution simulation using the kilometer scale, the atmosphere and the ocean component models. There's such very high resolution model, maybe a kind of leap to promise the incredible improvement in the climate simulations, but they are not yet ready to use for the CMIP experiments. So the second your point is the model have been continuously updated and evaluated, which are thanks to CMIP, I'll say, but the improvements are only incremental. Which means that we are aware that models will never be perfect, and we need to choose the right tool for the right job in the climate science. The one good example was taken from AR6. In that I was serving as a lead also to assess the Earth's climate sensitivity. I wouldn't have much time to explain details, but the final assessment of the ECS in the red box is not really dependent on the CMIP 6 simulations, but it is obtained by combining different lines of evidence, including the emergent constraint. So we can use the potentially biased climate model simulations to give rise to the useful emergent constraint to understand the climate change better. And ideally, we could combine the theory, observations, and climate model simulations to understand the climate feedback or climate change aspects. This is the example of the clear sky long wave feedback, but I need to skip this thing. And the third point, which I'll say is the model ensemble combined with theory and observations would be useful for understanding and narrowing uncertainty in projection. And yet, there are discrepancies between models and observations, which will lead to new challenges in the present era. The one example which I have been extensively working over the recent years is the tropical Pacific SST pattern change. And some of you may know that the observations on the top left shows the cooling in the eastern subtropical Pacific, which hasn't been reproduced in most of the CMIP 6 historical simulations. So given this, the model observation discrepancy, we identified the possible forced mechanisms that act to cool the eastern Pacific against the greenhouse gas warming, and then detect the model errors which prevent the GCMs to reproduce the observations. Okay, and finally, this is the closing the slide. The modeling, climate modeling community probably has never been easy to achieve the model, good model results due to both practical and conceptual problems. And seemingly now we are facing different kinds of problems, sometimes including the structural the ones. And of course, the CMIP 7 has already started, so we hope to resolve these new problems eventually. So I think the time is up. I'll stop here. Thank you very much.
Thank you very much, Masa. That was really interesting. Has anyone got any thoughts or questions for Masa? Please put it in the chat. Oh, we've got one. Is Stanilo?
Can you hear me?
Yes, we can. Thank you.
Oh, perfect. Hi. Recently, I've been working with a lot of climate models. And my question is, how comes that the ocean models that work very well without coupling, without atmospheric model, But once we add the atmosphere model, the models they're no good. The high latitude circulation is it's not real at all, or not even similar. I'm not talking about it's because they are low resolution models. AWI model, one of the best models in high resolution that we have so far, he is not able to reproduce the Arctic Ocean circulation. So where do you think is the problem?
Well, I think the increase in the resolution will improve the simulated the fields in ocean and atmosphere and in any components. But it's also true, once you couple the ocean model to the atmospheric model, the many potential errors could be amplified. A good example is the WITC bias, which is probably originated from the atmospheric model, but once you couple, then the WITC bias get worse. So we have seen such examples over time.
So how do you improve the coupling? Like, do you need to apply AI constraints? Because it seems very tough.
Yeah, it's tough, and there would be multiple ways to improve the model, as you say, using the AI. But still, I think expert judgments are critical to reduce the bias or errors in the component models.
Thank you so much for your reply.
Thank you. Helene?
Hi, Masa. Thank you. That was super interesting. I've probably got way more questions than I can ask now. But yeah, so a couple of things. It was great to see you highlight the tropical Pacific SST pattern problem. And in case you may be aware, but that's one of the questions that the CMIP panel are going to highlight for CMIP 7. So really great that you talked about that. With the climate sensitivity, I don't know what, it'd be interesting to know your thoughts, particularly having worked with the models and AR6. Do you think that a lot of the centers that were outside the AR6 range will work really hard with the tuning to get within the range? And what do we think about that?
That's a quite interesting the question. You know, we have seen some the hot models in CMIP 6, and I don't know how those hot models will be in CMIP 7, but for assessing the climate sensitivity, the hot models were not quite serious because we combine the multiple lines of evidence, but also it is useful to understand why the climate sensitivity was so hot in some models. Then, in the model tuning workshop, we agreed on no modeling centers use the climate sensitivity as a tuning metric.
Mm-hmm.
So the high sensitivity or low sensitivity could naturally happen through the tuning, the process. So I expected some CMIP 7 models still show the high sensitivities or low sensitivities. I don't know the probability distribution from the CMIP 7 model, but still the model ensemble is useful for understanding why the sensitivity is so spread due to cloud feedback or other factors, and so on.
Yeah, and it would actually be great to highlight that paper from the tuning workshop. I wasn't aware of it, and I know it's something we've talked about with Fresh Eyes on CMIP about transparency with tuning. So it'd be great if we can. I should go away and read it myself. So sorry about that.
Right. I remember talking with the Greg or someone in March. We may be able to arrange that kind of workshop again, gathering the modelers from the individual the centers.
Oh, that'd be great if WGCM could take that forward. So I have some other questions. I will email you.
Okay.
Thanks very much, Masa. That was really interesting. And yeah, I'm sure we will be able to ask you some more questions in WGCM as well. So thank you very much.
Thanks.